This video is for Module 1, Part 5, and includes a discussion of the Outlier Rule. Okay, let's go ahead and get started then. In Module 1, Part 5, we're going to continue with the parolee discrimination case that was discussed in Module 1, Part 4. For that simulation model, we were investigating whether or not Native Americans were being discriminated against in terms of their parole. There were a total of 59 Native Americans that were eligible for parole at the beginning of the study. So our number line is going to go from 0 up to 59. When we consider the proportion of individuals that received parole, that was 535 out of the 902 that were eligible. That percentage is 59.3%. So the 59.3% represents individuals that were, the percentage of individuals that received parole that were eligible. In an all things fair situation, we would expect that 59.3% of the Native Americans should be paroled. The expected quantity here is simply computed by taking 59 multiplied by 0.593, and that value is near 35. So the center of our reference distribution here is going to be centered right at 35. The study outcome produced a 24. So there's actually 24 Native Americans that were paroled. Which the question then is whether or not 24 is too few against this reference distribution. If 24 is too few against this reference distribution, then that's going to be evidence for discrimination. The table here provides a description of the relevant values from our simulation model. Again, the lowest possible value is 0, the largest possible value is 59, the expected value is 35. We're interested in the left side of the distribution, and the study outcome was 24. That's the number that actually received parole. Let's talk a little bit about how to obtain the reference distributions. Now, what we have been doing up to this point, is using the 2AFC app. The 2AFC app, you need to specify the two outcomes, provide probabilities for each of those, the sample size, and then when you click Run Simulation, what you get is one simulated outcome. So it's going to show you for each of the 59 individuals whether or not they were paroled. Now that works well if you're interested in the outcomes one iteration at a time. However, to obtain many simulated outcomes, it's going to be easier to use the reference distribution app. The link for the reference distribution app is provided here, and I will show you in a moment how to use that app. The probability of success, that is the 0.593. So when we're using the reference distribution app, the pi value is the 0.593. Now that is the same probability value that I used over here on the 2AFC app. So the probability for what you're interested in tracking, so here it is the individuals that received parole, is what probability goes in this box. The sample size, denoted by n here, is just the number of trials. The number of samples is where we specify how many repeated outcomes we want to obtain. So if we wanted to obtain, say, 1,000 repeated outcomes, I would put 1,000 in this box. Just some more comments about that app. You're going to want to deselect the Animate button, and then also on the right-hand side, over in the right margin, you're going to want to say Hide the Spinners. That'll help keep the screen a little less distracting. Also, on the reference distribution app, it did not ask for the labels. There's no label on the reference distribution app. So the number line is just generically labeled number of successes in this app. This is what the reference distribution app is going to look like for our simulation or our simulation model. And here I've specified the number of samples to be 5,000. To obtain the graph, all you need to do is just click the Draw Samples, and our reference distribution is obtained. Here you can see that I've clicked the Hide Spinners and also deselected the Animate. It keeps the screen a little cleaner, as I said. Okay, let's talk about the outlier rule. So again, the overarching goal in a simulation model is to gain an understanding or measure of the inherent variation that exists under the situation of no discrimination. Understanding this inherent variation will allow us to determine how likely or unlikely it is to see 24 Native Americans paroled. The definition of the outlier rule. An outlier rule determines the location in a distribution that separates the likely outcomes from the unlikely outcomes. The widely accepted percentage of outcomes to be identified as unlikely is 5%. This is often referred to as the 5% outlier rule. Now, in practice, the outlier rule is to identify 5% of the distribution as unlikely and the other 95% as likely. The setup of the investigation is used to determine which 5% should be identified as unlikely. So, if interest lies in the left tail of the reference distribution, and that's the case that we have here in the parolee discrimination example, and also in the deafness example that we considered earlier in Part 1 and Part 2 of Module 1. There we're interested in the left tail of the distribution. When you're interested in the left tail, you're going to want to use the bottom 5% and identify those observations as unlikely. If interest lies in the right tail of the distribution, that would be the staring example, then we are going to use the top 5% as unlikely outcomes. There's also a situation where you might be interested in both tails. In that situation, we're going to want to use the outside 5%. How do I find the cutoff value? So the reference distribution app can be used to determine the cutoff point for when a statistician would consider an observation to be an outlier. To find the cutoff point, we simply need to change the value in the As Extreme As box, which is right here. I provided a video to show you how to use the reference distribution app. I think I'll just go over to that app, plug in those values, and show you here as well. So for probability of heads, we want that to be the 0.593 value. The 59, let's go ahead and obtain 1,000 outcomes. Deselect Animate. Over here in the right margin is the Hide Spinners. And then say Draw Samples. And if you want more samples, you can just keep selecting Draw Samples here. And here is the As Extreme As box. So there's where we're going to be putting in various values for the cutoffs. So what happened, or let's go ahead and talk about proposed cutoff values here. So here, using the reference distribution app, I actually typed in 10,000 repeated outcomes. Again, using 10,000 repeated outcomes is going to make sure that that reference distribution is settled down and doesn't have any small anomalies, etc. So when I put in As Extreme As 28 here, and again I'm using the left side of the distribution, so I need to make sure that that inequality is on the left, and go ahead and click Count. What that's going to do is count the number of dots that are to the left of 28 for me. There are a total of 443 of the 10,000 dots lie at or below 28. This is 4.3%, which is just below the desired level of 5%. So at least tentatively, a value of 28 looks like it does a pretty good job of separating the likely outcomes from the unlikely outcomes in this distribution. Let's go ahead and try a proposed cutoff value of 29. So again, everything else is the same. Only thing I've changed here is instead of putting 28 in that box, I have now 29 in that box. There is a total of 739 of the 10,000 dots lie at or below 29. 739 divided by 10,000 is about 7.4%, which exceeds the desired level of 5%. So a value of 29 is a little bit, the value of 29 produces a probability which is a little bit above 5%. For that reason, we'll go back and use the proposed value of 28, because this probability value here is just underneath 5%. Again, our target is to get this as close to 5% as we can, and I usually use the idea that I don't want to go over the 5%. So using the 5% outlier rule, the 5% outlier rule suggests that a reasonable cutoff value would be 28. So there's a connection between the outlier rule and what some call the error rate. I provided a discussion here, which I'll let you read. Okay, so let's recap what we've learned here. The question of interest is there enough statistical evidence to suggest that too few Native Americans were paroled against a no discrimination situation? The answer to that is yes. The simulation model suggests that 24 would be an outlier against a situation of no discrimination. Again, the expected would be 35. We've determined through our simulation model that any value at 28 or less would be considered statistically unlikely and would provide evidence for discrimination. The study outcome was 24, which certainly sits to the left of 28, thus suggesting that 24 is indeed some evidence for discrimination. Okay, that does it for Module 1, Part 5. This module didn't have any questions for you to answer, so I've just put a confirmation box at the end. So just simply put your name in there and click the submit button.